NASA is preparing to send humans back toward the moon for the first time in over 50 years. But behind the headlines, something has changed. Delays, technical concerns, and new information about the risks of deep space travel. Artemis II is still moving forward, but not exactly as planned. And what NASA has revealed recently might change how we see the future of human space exploration. Artemis II is currently targeted for launch no earlier than 2025, but that date has shifted multiple times. And that's not unusual. Deep space missions, especially crewed ones, require extreme precision. After the success of Artemis I, NASA didn't rush forward. Instead, they slowed down to analyze every detail of the mission. Artemis I proved something important. Orion could reach the moon, operate in deep space, and return safely. But it also revealed issues, especially with the heat shield. During re-entry, Orion experienced unexpected wear on its heat shield. Not failure, but behavior that NASA didn't fully predict. And for a crewed mission, not fully understood is not acceptable. Re-entry is one of the most dangerous parts of any mission. Temperatures reach thousands of degrees. If the heat shield fails, there is no backup. Engineers have been analyzing data, running simulations, and adjusting how the spacecraft will behave during re-entry, including entry angle, speed, thermal protection performance. The heat shield isn't the only issue. NASA is also refining life support systems, crew safety protocols, and software reliability. Every adjustment, every delay, every test brings NASA closer to one goal: sending humans safely into deep space. But even with all these improvements, there's something NASA cannot fully simulate. Something unpredictable, something that only happens once the mission begins. And it may be the biggest unknown of all.
Rockets can be tested. Systems can be upgraded. Software can be rewritten. But there's one part of Artemis II that can't be replaced: the crew. NASA selected 4 astronauts for Artemis II, each with years of training, experience, and responsibility. The crew includes Reed Wiseman, Commander; Victor Glover, Pilot; Christina Koch, Mission Specialist; Jeremy Hansen, Mission Specialist. This is not the Apollo era. Artemis II represents a new generation of astronauts, more diverse, more international, and preparing for missions far beyond what previous crews experienced. For the first time, a Canadian astronaut will travel beyond Earth orbit, selected by the Canadian Space Agency. This mission is no longer just national, it's global. Training for Artemis II goes far beyond normal spaceflight preparation. These astronauts must be ready for deep space navigation, communication delays, system failures, medical emergencies without immediate support. NASA runs full mission simulations, from launch to lunar flyby to re-entry. Every scenario is tested: loss of communication, system malfunctions, emergency procedures. Astronauts are trained for worst-case situations, because in deep space, there is no rescue mission. Every crew member has a specific role, but they must also function as a unit. Trust, communication, decision-making become critical in high-stress environments. One of the biggest challenges isn't physical, it's psychological. Being far from Earth, isolated, completely dependent on the spacecraft. During the mission, the crew will see Earth from a distance few humans ever have: a small blue sphere surrounded by darkness. Many astronauts describe something known as the overview effect, a shift in perception when seeing Earth from space, a realization of how small and fragile it really is. Unlike missions in low Earth orbit, Artemis II crew members must make decisions independently, because communication delays mean help isn't always immediate. Every decision matters. Every action has consequences. And in deep space, mistakes are not easily corrected. These astronauts are not just flying a mission, they are proving something, that humans can operate safely beyond Earth again. Because no matter how advanced the technology becomes, the success of Artemis II depends on the people inside the spacecraft. And even with all their training, all their preparation, and all their experience, there's one part of this mission they cannot fully prepare for: the environment of deep space itself. And what it does to the human body may be more dangerous than we think.
Artemis II isn't just a repeat of past missions. It's a redesigned path based on new data, new technology, and new priorities. And recently, NASA has made adjustments that reveal just how complex this mission really is. Artemis II will follow a carefully planned trajectory, not a simple orbit, not a landing, but a deep space flight path designed to test everything. The mission begins with liftoff from Earth, powered by the Space Launch System. Within minutes, the rocket reaches space, boosters separate, and Orion continues toward orbit. Before heading to the Moon, Orion will enter a temporary orbit around Earth. This allows NASA to check all systems, verify crew conditions, and prepare for the next critical burn. Then comes one of the most important steps: translunar injection, a precise engine burn that sends the spacecraft toward the Moon. Timing here is critical. Even small errors could send the spacecraft off course. Based on recent mission planning updates, Artemis II will follow a free return trajectory. This means if systems fail, the spacecraft can naturally return to Earth, using gravity alone. This trajectory adds a layer of safety, but it also limits flexibility. Everything must be calculated in advance. The spacecraft will pass approximately 7,000 to 10,000 kilometers from the Moon's surface, close enough for detailed observation, but far enough to maintain mission safety margins. As Orion moves behind the Moon, communication with Earth will be lost. This is expected, but still a critical moment. Artemis II is expected to last approximately 8 to 10 days, including travel to the Moon, lunar flyby, and return to Earth. Since Artemis I, NASA has refined flight software, navigation systems, and autonomous controls, making Orion more reliable and more capable of handling unexpected situations. After analyzing Artemis I data, NASA has updated how Orion will re-enter Earth's atmosphere, adjusting entry angle, flight path, and thermal performance expectations. At these speeds, even a small miscalculation can lead to excessive heat, structural stress, and mission failure. Artemis II will fully test human life support systems, including oxygen supply, carbon dioxide removal, and temperature control, systems that must function perfectly for crew survival. Orion is designed with multiple backup systems, because in deep space, failure is not an option. Despite all updates, some things remain the same. The mission is still high risk, the environment is still hostile, and the margin for error is still small. Every update improves safety, but also highlights something else: how difficult this mission really is. And even with all the planning, all the adjustments, and all the technology, there are still forces beyond human control. Economic pressure, political decisions, and the reality of funding a mission this complex. And those factors may shape the future of Artemis just as much as science does.
Artemis II isn't just a scientific mission, it's also political, economic, strategic. Because returning to the moon is no longer just about exploration. The Artemis program is one of the most expensive space initiatives in modern history. Estimates place total costs in the tens of billions of dollars, and each launch of the Space Launch System costs billions on its own. Deep space missions require advanced technology, extensive testing, and long development timelines, and above all, absolute reliability. Not everyone agrees on the cost. Critics argue the money could be spent elsewhere. Supporters argue space exploration drives innovation and long-term progress. NASA doesn't operate in isolation. Its funding comes from the government of the United States, which means political decisions directly impact the mission. Launch timelines aren't just technical goals, they're also political commitments. Delays can affect public perception, funding decisions, and future missions. Artemis is happening in a competitive environment. Other nations are advancing rapidly, especially China. China has announced plans to send astronauts to the moon, build a lunar research station, and expand long-term presence. This adds urgency to Artemis. Unlike the Apollo era, Artemis is built on collaboration. Agencies like the European Space Agency, Canadian Space Agency are contributing technology and expertise. This mission represents a shift from competition to cooperation, but also from exploration to present. The moon isn't just a destination anymore. It may hold water ice, rare materials, or strategic positioning for future missions. Establishing a presence on the moon raises new questions. Who controls resources? Who sets the rules? Who gets access? To address this, NASA and its partners introduced the Artemis Accords, a framework for peaceful exploration, cooperation, and responsible use of space. But not all countries agree, and as more players enter the race, tensions could increase. Artemis II is not just a flight test, it's a signal, a statement that humanity is moving beyond Earth again. Because if Artemis II succeeds, it accelerates everything: moon bases, Mars missions, and a permanent human presence in space. But if it fails, the consequences won't just be technical, they'll be global, and they could reshape the future of space exploration entirely.
For decades, humanity has remained close to Earth, orbiting it, studying it, observing from a distance. But now, we are preparing to go farther again. Artemis II is more than just another mission. It's a turning point, a moment where exploration shifts from near-Earth operations back to deep space. If Artemis II succeeds, it proves something critical. Humans can safely travel beyond Earth again, not once, but repeatedly. That success leads directly to the next step, Artemis III, a mission designed to land astronauts on the moon once again. But this time, it's not temporary. Artemis is designed to create long-term presence, including lunar surface missions, orbital stations, and continuous exploration. Space exploration doesn't just change space, it changes life on Earth. Technologies developed for missions like Artemis often lead to scientific breakthroughs, new industries, and global collaboration. But the moon is only part of the plan. Everything leads to one destination: Mars, a planet millions of kilometers away, with challenges far greater than anything we faced. Even if Artemis II succeeds, the dangers remain. Deep space is still unpredictable, harsh, and unforgiving. This is where we are now, standing at the edge of something unknown,
deciding whether to stay where it's safe or move forward into uncertainty. The astronauts aboard Artemis II are not just completing a mission, they are opening a path others will follow. Just as the Apollo missions defined a generation, Artemis may define the next one, a future where humans live and work beyond Earth. This mission is not the end of a journey, it's the beginning of a new one, somewhere beyond the moon. Beyond the missions we've already planned lies a future we are only beginning to imagine. And for the first time in decades, we are taking real steps towards it. The question isn't whether we will return to the moon. The question is how far we're willing to go beyond it. Subscribe to Obscura Cosmos because this mission is just the beginning, and the next step could take humanity farther than ever before.